This is the video recording for quiz number 1, the answers to it. The first question is asking you to draw the Lewis structure for two molecules whose molecular formulas are given, and also you have to figure out the hybridization at the central atom. So for the first structure, we can actually draw two of them here. One where you can make the carbon attached to 3 hydrogens, which is attached to another carbon, and then with a triple bond to nitrogen and lone pairs. So this is one structure. If you draw it like this, the hybridization at the carbon atom are sp3 here. This is sp. Okay, and if it was asked for nitrogen, nitrogen will also be sp. The other way by which you can draw the structure is still keeping the octet rule intact, violating the octet rule. So you can draw a triple bond to the carbon, and then with two hydrogens attached to the nitrogen. Okay, so this also covers 2, 4, 6, 8, 10, 12, 14, 16. This was 2, 4, 6, 8, 10, 12, 14, 16, right? 16 valence electrons. So this is also a correct valid structure. And in this case, both the carbons are sp hybridized. Okay. The next one is asking you, there's one more, BF3. So the structure for BF3 is hexagonal planar kind of structure, where boron is happy to be having an incomplete octet, because if you recall, we had discussed that boron, if it forms a double bond with one of the chlorine atoms, then it gets a formal charge, which is not what we want. Okay, so this is the best Lewis structure where all the atoms have 0 formal charge. And then the hybridization of the central atom in this case would be sp2. Alright. The next question is asking you how many carbons and hydrogens are present in the following compound. So if you have to count every carbon. Okay, so let's mark it all the carbons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay, so we have 13 carbons, 13, and then hydrogens, if you count, each of these carbon here, they have only one hydrogen. Okay, so they only have one hydrogen here. There is none here, and then this one has 3 hydrogens at the end. Each of the carbons here, they have 2. Okay. And then here we have 1. Okay. So 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, then there is 1 here, right? That would be 17. So, I think I'm missing one. There should be 18 hydrogen atoms. So we have 1, 2, 3, 4, 5. Then we have 1 here. Yeah, there it is. Okay, 6. Then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And don't forget the hydrogen on the oxygen atom. So we have 18 hydrogens and then oxygens. Okay, so these are the number of carbons and hydrogens. The next one is asking you to indicate the correct hybridization for all the indicated carbon atoms. So we have this carbon, which is connected to a hydrogen, a CH3, and then it has a double bond here. So that will be sp2. This carbon here is sp. This carbon here, 1, 2, 3 electron clouds, is sp2. And this carbon with 4 electron clouds should be sp3. Next question. illustrate or draw sp2 or sp3 hybridization using an example. You can use any example for sp2. For example, if I use the methylene, the butene as my example for sp2, the structure of that. So these two carbons here, they are sp2 hybridized. So the way you can show them is with hybrid orbitals drawn. So this carbon, both of them have hybrid orbitals. And remember that in an sp2 hybridization, the hybrid orbitals are at the corners of a signal planar structure. Okay, so we can see the overlap here, right? And then we have the sigma. This is a sigma bond, and then we have the unhybridized p orbital on each of the carbon atoms, right? They also have one electron each, so this will result in a pi bond. Okay. Then don't forget to draw the hydrogens. So we have the hydrogens here, 1, 2, 3, 4, that's the s orbital, and you can draw the 2 electrons in each of these overlapping region. They all have 2 electrons. Okay? So one is from the hydrogen and one is from the hybrid orbital here. They overlap, so you have a sigma, another sigma here, another sigma here, and one more sigma here. Here also you have the 2 electrons, and then these orbitals overlap to give you the pi bonds here. Okay? So this will give you the pi bond. That's why you have a pi bond here, and then you have a sigma bond. An example of an sp2, and if you were to draw an sp3, then say for example methane. If you take methane as the example for sp3, then again you can illustrate that by drawing the 4 orbitals, 4 hybrid orbitals at the 4 corners of a regular tetrahedron, which are overlapping with the hydrogen atoms. So you have the s orbitals of hydrogen atoms. We have 1, 2, 3, 4, right? 4 hydrogens, and again you can draw the 2 electrons in each of these orbitals overlapping from the sigma bonds. Here we only have sigma, 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 sigma. So again, remember the green s orbitals are for the hydrogen atoms. These are the red ones are the hybrid orbitals. Here in this case also, let's keep it the same color. So you have hybrid orbitals in red color. So carbons, sp3 hybrid orbitals at the 4 corners of a regular tetrahedron. Now the next structure, or the next question, was asking you to draw the skeletal structure for the following condensed formula. If you look at, we have 1, 2, 3, 4, 5 in this carbon atom chain, and then we have one branch coming out. The one in parentheses tells us that there is a branch. So I'll go ahead and draw the carbons here. So we have 1, 2, so that's the one that's a branching. So 1, 2, 3, 4, and 5. 4 and 5. So that includes the carbon for the carboxylic acid. So the only way you can draw this at this end, this OH, is by forming a double bond to oxygen and a single bond to this oxygen. Okay, and then we have the CH3 that was in parentheses. That's this one, and then we also have to draw the Br on this one. Okay, so if it helps, you can number them. So we have 1, 2. Don't number the branch because that's going to come out. So then we have a 3, and then 4, and then 5. So this is, I just randomly numbered from one end. I haven't followed any rules of numbering. I just put the numbers so that you can track them here. So this is 1, then we have 2, then we have 3. So 1, 2, 3, 4, and 5, right? So if you look at the third carbon atom, we had a Br, so that's why I put the Br here. And the second carbon atom, there was a branch, so that's the branch that's coming out here. Okay. So sometimes, numbering might help so that you don't lose track of the carbon atoms in this structure. The next one was asking you to draw a structure that contains 4 carbon atoms which are all sp2 hybridized. So you can do that by putting double bonds here, right? So we have this carbon atom is sp2, this is sp2, this is sp2, sp2. That's like a skeletal structure. Or if you want to draw the structure with hydrogens in it, you can go ahead and draw. There is a hydrogen here, there is a hydrogen here, we have hydrogens here. This is 2 hydrogens. Okay? But if you look, they are all the carbons here are sp2 hybridized. This is sp2, this is sp2, this is sp2. So they are all sp2 hybridized. Next one was how many sigma and how many pi bonds are there. So if you count, there are only 3 pi bonds. So we have 3 pi bonds. And then how many sigma? 1, 2, 3, 4, 5, 6, 7. Okay, so there are 7 sigma bonds in this molecule because you are having hydrogens connected to the carbon, which are also sigma. So sometimes it helps us to elaborate the structure and write it like this, where you clearly show the bonds to the hydrogen. Okay, so you have 1, 2, 3, 4, 5, 6, and 7. So we have 7 sigma bonds. Finally, the last question was asking you to attach as many hydrogen atoms. So remember, carbon can form 4 bonds, so the structure would be CH4. Oxygen can form 2 bonds, so it is water, H2O. Nitrogen can form NH3, and then for chlorine you have just 1 bond, which is H3. So that's the number of hydrogen atoms you will put for each of these atoms that were given. So that's the end of the quiz, a very simple quiz, and I think that if you have any questions, please let me know. It was a very basic review of general chemistry, and you can continue to study the next chapter, which is on formal charges and resonance and acid-base, etc.